Hello, my name is Farrugia from the University of Malta, and on behalf of my research team, I welcome you to my presentation titled DFX Lessons Learned from VR Controllers. This is part of the work that we are conducting in the PRIME VR2 project. So let's start off with some background to the PRIME VR2 project. The overall aim is to deliver a platform that integrates bespoke VR hardware and physically and socially optimized gaming in order to provide an enhanced VR experience. We are taking 3 target users as case studies, namely children with dystonia, sports injured patients, and also post-stroke patients. As you can see from this slide, given the nature of the project, we have a number of members in the consortium spread across Europe, ranging from experts in the medical field to software developers and product development experts. Our role as University of Malta in this project is to produce a mechanically sound integrated structure of the controllers able to incorporate all components and survive use in service. To achieve this overall aim, our first task concerned the analysis of a sample of existing controllers on the market from a design for manufacture and design for assembly DfMA perspective. So, why going for DfMA? As you can see from this chart, the decisions taken at the conceptual design stage have a lot of consequences of the subsequent stages of product development. In fact, from this chart one can say that although 20% of the actual costs are allocated to the total project cost, in actual fact 80% are committed. Therefore, one can appreciate the importance of taking good decisions at an early design stage. In order to accomplish this, the designer has a range of tools available to use at different stages of the product development, and precisely the DfMA is one of these tools. Such an approach will enable the designer not to take an overall approach, in the sense that the designer can foresee any potential consequences, unintended of course consequences, during the late design stages, which would be very costly to change. If we look at the approach that one can take when it comes to DfMA, normally one starts with a design for assembly. Why? Because one has first of all minimize the number of parts to reduce the cost and also to reduce the assembly time. Also, we need to optimize for assembly. For example, we need to take certain decisions on the assembly direction of various components making up a product. Then we proceed to design for manufacture. Here we have to select the best process, the best materials, the tolerances which would enable the product to function correctly, and also to optimize the process. If we take this simple example, we are seeing here a peg made from the traditional peg made from wood and a spring. As you can appreciate, this poses some challenges during the assembly stage. Whereas if you look at this design, one can appreciate that it has less components, therefore facilitate the assembly process. If we take a specific example of a DfMA exercise in which I was involved, here we are seeing concept sketches of a modular surgical instrument aimed to be used by surgeons to remove metastases, which are cancerous cells which propagate from one organ to another. After selecting the best concept, as we can see here in this diagram on the left, we have analyzed the tool using DFA. As you can see on the diagram on the right hand side, the number of parts drastically reduce. Therefore, we have reduced considerably also the assembly time, and therefore we improve the performance matrices of the product. Now, returning back to the PRIME VR2 project, so we have DfMA is branched into DFA, the design for assembly and design for manufacture. When it comes to DFA, which is the focus in this presentation, we applied a number of guidelines, DFA guidelines on current controllers, and to achieve this we have gone through an exercise, a tear-down exercise of 3 state-of-the-art VR controllers. When it comes to design for manufacture, since the controller will be designed using additive manufacturing, we have also looked into design considerations for additive manufacturing. But as I mentioned previously, the focus in this presentation is on DFA. As you can see from this slide, the 3 controllers which were taken as case studies are the HTC Vive, the Oculus Touch, and the PlayStation Move. As I mentioned, we have taken examples of guidelines from each controller, and from the analysis it resulted that the PS Move uses the most DfMA principles. As you can see from this picture over here, first we have visualized each controller. This is just an example of the HTC Vive. So we have visualized the assembly of the controllers before being subjected to a tear-down exercise under X-ray. Okay, so we would have an idea of all the features that constitute such product. Then we have disassembled the part and outlined what is called a product breakdown structure. And this chart over here is illustrating the product breakdown structure of the HTC Vive base assembly. As you can see here, we have a number of parts. Now, this slide summarizes the 6 principles that we came up with following our analysis. The first one concerns mistake-proof product assembly, where pins are used to guide components assembly. The second principle regards vertical assembly. We have noticed that most components can be assembled from above and have self-locating features. In terms of alignment, we have observed that lips, ribs, and pins are used to align the assembly of parts. We have also noticed the use of tapers, which facilitate a lot assembly because chamfers help in the guiding of parts in position. In terms of joining, we have observed the heavy use of adhesive and also the use of integral attachment methods, such as screws. Then we have also looked into the orientation. We have seen that symmetrical parts for automatic feeding are used, and also asymmetric parts for ease of orientation. So, in a nutshell, those were the 6 main principles which we observed from this exercise. If we take a closer look, in this slide we are seeing the use of snap fits in HTC Vive and in the PS Move. Of course, the use of snap fits instead of, for example, screws will help a lot the assembly process, because we have less parts to be assembled, and therefore we are reducing the time to market. This is another example where we have the use of the lip feature in the HTC Vive and in the PS Move button. So they are highlighted as you can see over here, and again such lip feature will help a lot in locating the 2 parts together. It's good to mention that as part of the project, as part of our package 4, we have generated a detailed report on our findings. So its title is Design for Manufacture and Assembly Guidelines, and it's a public report. And as you can see from these excerpts of the report, we have gone into quite a lot of detail on the use of the DFA philosophy on the current controllers. So, in summary, what are the key takeaways from this exercise? It is concluded that, in general, DFA rules are applied in current controllers, in particular, by reducing the number of parts, by combining parts together, simplify the design as much as possible, facilitate the assembly process by having vertical stacking, adequately sized symmetrical parts, guiding pins, and self-locating parts. We have also concluded that DFX philosophy must be applied to take into account other factors related to the development of VR controllers used for rehabilitation purposes, in particular design for hygiene. So this marks the end of my presentation. Thank you very much for your attention. If you would like to have any further information on this project, do not hesitate to send me an email, as you can see on this slide. Thank you.